Find the general solution to this thing. We're going to multiply over the 6y squared and then multiply over the dx. This is very, do these steps, get your answer, straightforward kind of thing. All right, so antiderivative for 6x squared, what's that? Or 6y squared, excuse me, that's going to give you what? Yep, good. Equals 1/2 x squared plus 4x plus c. And you're not going to figure out what c is. It says general solution, so that means infinite number of answers. I just wanted to make sure. All right, so we're just going to solve it for y. What would you do to both sides? Yep, divide by 2. Did you guys say that back there? So divide by 2, and then cube root. I'm not going to recopy it because I don't feel like it. I'm going to just do that. Cool. Find the general solution to this thing. All you're going to do is multiply over the dx. When that happens, I tend to put a 1 in front of the dy. That's a personal preference. If you don't want to do that, you don't have to. I just find that if it's blank, it throws everybody off. Now, the good thing about this one is, what do you end up with on the left side? Yeah, just y equals. The bad news is there's trig, okay? You need to come up with a trig function. There are only 6 of them, and I'll give you a hint, it's not sine or cosine, but one of the other 4 that if you did the derivative, you would get negative cosecant squared. Like, that's the answer. Cotangent. And the negative is even in there, so it is just cotangent of x plus c. Boom, that's the answer. Move on to the next one. The derivative of cotangent is negative cosecant squared, so that's all that there is. All right, this one is a particular solution with an initial condition. So we are going to find what c is. To move this y minus 3 over, we are going to need to divide. So it's going to look like this. Sorry, I try to write it fast and then get my hand out of the way so you can see it. Equals x minus 1 dx. Antiderivative. Pretend the minus 3 isn't there for a second. What would be your antiderivative of 1 over y? Yeah, ln. So it's going to be ln y minus 3 equals 1/2 x squared minus what? Yeah, good, just x plus c. Then we're going to plug in our initial condition, but this is the step we're going to have to come back to if you want to like put an arrow. All right, so we're going to plug in 6 for x, 4 for y. It's good that it's 4 for y because this is non-calculator. 4 minus 3, 1 ln of 1, 0. That's really the only one you can do without a calculator. Unless anyone knows what like ln of 7 is without a calculator. All right, plugging in 6. 6 squared, 36. Half of that, 18. Minus 4 plus c. So what is c going to be? Yep, negative 14. Good. So the step that I put the arrow on, you're going to literally recopy that, like exactly like it looks. But instead of plus c, you're going to put minus 14. Go ahead. Okay. Oh, good call. I'm sorry. Yeah, x is 6. I'm so sorry. Thank you. I don't have to erase everything, though. Yeah, that's going to make that negative 12. Thank you. Crisis averted. Now, you'd be okay because it's multiple choice, and that wouldn't be one of the answers. Hopefully.
That would be so mean.
Sometimes it is. Well, they are mean, you know. All right, now we're back on track. Thank you. All right, so how do you cancel out ln? It's e exponentiate, so it's going to be e to the power of all that. Yeah, just like that stuff. And then to get rid of the minus 3, you would plus 3 at the end. Typically for an absolute value, you get plus and minus, but do you see how your initial condition is positive? So you just want the positive version of that. Are you okay? Yeah, I saw you trying to see around the glare, so I moved it. All right, we're going to try that again. We need to move the y to the other side. So I'm going to divide that over. And again, I've been getting asked, so I'm going to address it. Why didn't you bring the 2 as well? You can, but at the end, you need to get y by itself. So the less stuff you move over to the left, the less stuff you're going to have to move back over to the right at the end. So I'm trying to save myself some work. So I'm going to leave the 2 where it is, multiply over the dx. All right, so that is, again, going to give you ln. So lny equals, all right, I need a trig function that if I did the derivative, I would get sine. Negative cosine. So this is -2 cosine x plus c. When we come back, that's the step we're going to have to come back to. Like, that's what I'm going to recopy. Oh, we get to do some unit circle. We're going to plug in pi for x and e cubed for y. If you plug in e cubed for y, the ln and the e cancel, you will just get 3. Now, where is pi on your unit circle? Over here, right? Left? Cosine is the x part of the point. So that is -1 times -2 is just 2 plus c. I can show you that. It came out to this. And then these cancel. So just 3. All right, so what is c going to equal? 1. Go ahead.
So if you divide by 2y, would it still be the same thing?
No, you would get a different c value because you're kind of taking a different path to get to the answer, but your answer at the end will end up the same. Because when you go to solve it, you're going to then undo those steps. But if you did it that way, your c value will not be the same, but your answer at the end should be the same. Okay. So we're going to recopy the line that I put the arrow on there. Oops, if I could write here. Except instead of plus c, you're going to put +1. And then you're going to exponentiate. And again, your initial condition is positive, so we don't need a plus minus for that absolute value. Yay! These are very dry, very boring. Just do these steps. But again, a lot of people end up liking that. So. All right, how would you separate the variables for number 5? Yep, divide by y. And then multiply dx. Are you seeing that they like ln? Like, I'm modeling this after what I found on AP Classroom, and a ton of them were like that. So they like to do that. So it's going to be lny equals, all right, antiderivative for 1/2 x. Good, 1/4 x squared plus c. All right, so that is the step that we're going to come back to. We're going to plug in 0 for x and 4 for y. So this side would just be ln 4, whatever that is. And x is 0, so that actually just is your c value. So we're going to recopy this, but put in ln 4 for our constant. And then you will exponentiate. E and ln are going to cancel. You'll just have 4, and we write that out front. So it's going to look like that. Now, this one has one more step. You don't get to just stop there. It says, then find what? F of 3. So you're going to have to plug 3 into this. So 3 squared, 9, be 9/4. So 4e to the 9/4, whatever that is. Some kind of decimal. That's your answer. So there's just one extra step where you had to plug in the 3. Oh, this one's a little, oh, go ahead. So whenever you exponentiate, you get this. Because when you add, you multiply. The e and the ln cancel, you just get 4, but we put that out front as a coefficient. It also looks kind of like that Kecht formula. Do you remember PERT? Sort of like, you want to think of it that way. This one is a little bit different because it's not just y. When you divide this over, you will get this, but that is not ln. ln is only for 1 over y. If there's another power in there, it's not going to be ln. So you want to write that as a -2, and then we're going to have to, do the problem like we do every other problem. It's not like a special case with an ln. All right, what's still on the right side? Yep, 3x, then you're multiplying over the dx. So be careful because this is negative. You're going to add 1 to the power. So it's going to become less negative. It'll be -1. And then that means a negative in front of that. I'm going to erase and fix that in a second so that we don't have a negative exponent. But let's do this side first. This would be 3 x squared plus c. Let me look ahead, see how far I'm going to go before I get great. I'm going to erase that. How can you rewrite that so that there's not a negative power? Yeah, -1 over y. So I'm going to just go ahead and fix that. And this is the step that we're going to come back to. We're going to plug in 4 for x and 1 for y. We'll go through 17 because that's where the free response starts. Sorry, question? No, okay. So 4 for x, 1 for y. If you plug in 1 for y, this is just going to be -1. If you plug in 4 for x, all right, 4 squared. 16 divided by 2, 8 times 3 is 24. So C is -25. We're going to recopy the step where I put the arrow, like literally just recopy it, but put a -25. And now mathematically, here's what's happening. This y gets multiplied over, and then all of this gets divided over. So they are simply going to swap places. The one on your quiz was just like that, and you guys did really well with it. So I believe in you. What is going on? Usually have to fuss at you guys. Exactly what you think it means. All right. Yeah, I'm gonna go through 17 and then we'll do our halfway break because I feel like that's getting to that'll get us to the free response. Yeah, that was it. That was find the particular solution, and we did. Yeah, that's it. All right. For this one, there's not a y in there. So again, when that happens, I like to put a 1 there. You're just going to multiply the dx over. Is that okay? Sure. So the nice thing is that will just be y equals, which is great. I need a function. If I did the derivative, I would get cosine. So sine, good. So 4 sine of x plus c. Ooh, more unit circle. We're going to plug in pi over 2 for x, -1 for y. So this is the step we're going to come back to. We'll have -1 equals. All right, where is pi over 2 on the unit circle? Oh, okay. Sine is the y part of the point. So 1 times 4 is 4. Good job. You guys are good on your unit circle. And so C is -5. So I'm going to recopy that step where I put the arrow, except put in the -5. And then that's it, because y is already by itself. This one's written in words instead of with a dy dx, but what's the important word here? Slope. So your dy dx is 4x minus 1. And you're going to do the same exact thing that we did for all the other problems. It's just written in words instead of like giving you the problem. So you're going to multiply over the dx. This is very drill in practice. Like just do the same thing over and over and over again. So that's going to give you y equals 2x squared minus x good plus c. We're going to plug in -3 for x and 5 for y. So this will be the step we come back to. I kind of just ran out of space. But y is 5. All right, -3 squared, 9 times 2, 18, minus -3, so plus 3 plus c. So is that 21? So 5 minus 21, -16. And so I'm going to recopy this step with the arrow with a -16 in it. It's always nice when y is already by itself, because then you don't have to do all the algebra of like rearranging it. Heads up for this next one. It's going to look horrible. The math we're going to do is not actually that bad, but you're going to write a little bit just as a heads up. Okay. But I don't feel like we've done anything too terribly difficult so far, right? Just do the same thing over and over again. This is the first one that I would say is like a little bit more annoying. Do you see how this says y? Y equals. Do you see how that says y prime prime? You're going to have to do 2 derivatives. So just as a heads up. So here we go, right? Kind of small. Y prime equals. Now, k is a number. It's kind of just there, okay? What's your derivative of e to the -2x? E to the -2x. Chain rule. Times -2. Okay, so it's going to look like this. You can put a little chain rule dot and put the -2 at the end if you want, but it looks cleaner this way, so that's how I'm going to write it. No, we're going to find k at the end. K is kind of our goal. Okay? Yeah, no, yeah, just trust the process here. All right, derivative of cosine, negative sign. So it's going to be negative, but there's another chain rule. You're going to have to multiply on a 3. So what would be out front? 12. Good. 4 times 3 is 12. Thank you for coming with me on that. It doesn't, but it's going to be messy. So you want it to look kind of as cleaned up as possible. It's not wrong, but it looks nicer this way. All right, buckle up. We're going to do it again, kiddos. Prime prime. Same exact thing for this, but you're going to have to chain on another -2. So out front, you will have 4. Good. Derivative of sine is cosine, but you're going to have to chain on another 3. So out front, good. Perfect. Nice job, guys. Equals. And over here, what would I have to do to get the y prime prime by itself? Yeah, subtract the 9y to the other side. So this is going to equal 26 e to the power -2x. Now it's minus 9y. Y is this thing. Do you see what I'm circling there? So you're going to have to multiply a -9 to both parts of that. As a heads up, we're practically done. After this, it's going to get better, I promise. Thanks for hanging in there with me. So if you multiply a -9 to both parts of that, you're going to get minus 9k e to the -2x. And if you multiply -9 to that part, okay, the horribleness is done. We got through the worst of it. I want you to stop, take a deep breath, step back, look at what we have, because you should notice something now. And this is where you kind of have to trust the process and see what you've got here. Do you see how you have the exact same thing on both sides? What does that mean you can do with that? Cancel it out. That minus 36 blah, blah, blah is gone. And then look through, what else do you notice? Because we've got k You can combine those. If you add this 9k e to the blah, blah, blah over here, 9 plus 4, 13k e to the negative 2x equals 26 e to the negative 2x. And then what cancels? Yeah, the e to the negative 2x is gone. You'll divide over the 13, and 26 divided by 13 is 2. Let me recap because that was a lot. We found two derivatives. We set it equal to this thing, and then we kind of canceled out the stuff that was able to go away there. Okay, so for this one, I showed you choices. This is exactly what it looks like. It says, which of the following is the solution of this? You can't actually, and this is why I had to give you choices, you can't actually solve this. This is what's called non-separable. What is the only way you could get the y to the other side? You would have to subtract it. That's not a thing. You would have dy dx minus 4y. It's not going to work. It's what's called not separable. So what you would have to do is do the derivative of each of these until you get this answer. For the sake of time, I'm going to tell you that it's d, and we'll just work out that one. But you would do the derivative of each of them until, like, you would test each choice. Do you get what I'm saying? Yeah. Okay. So what rule would you need to do this derivative? Wait, product and chain, you're both correct. All right, how does product rule start? All right, the first thing. Minus what times? Derivative of the second. Now that would be e to the 4x times 4. Good. So first times derivative of the second plus the second thing, derivative of the first, derivative of negative x would be negative 1. So look at this term right here. Do you see how that would be negative e to the 4x? That's this right here. And then it's plus 4y. Well, what did y equal in the first place? Negative x e to the 4x. So do you see how this is the 4 right here, and then the other stuff is what y is? Yes, I will. This right here is the negative e to the 4x. Those match. And then it's plus 4y. So here's your 4. This other stuff is what y was in the first place. So this is your 4y. So that's why it matches there. So your answer is D is in dingo. But you would just test each choice until you got it to work. To be clear, A and B don't make any sense because they aren't even a product rule. So you won't get a plus in there. So you can kind of narrow it down to these two. And do you see how there's a negative? Like, you're going to be able to narrow it down. Okay. Draw a slope field. On your test, it's matching. On here, I'm going to have you draw a slope field. Whenever you draw one, just go 2 units in each direction. And you can put the little dots in there if you want to or not, but like, we're just gonna. Yeah, again, I'm perfectly honest with you. I always try to be very blatantly honest with you. I don't really have much patience for drawing slope fields. I find them incredibly tedious. However, I think that they are cool. Like, what they are is neat. Just don't like drawing them. Where is this going to be indeterminate? Yeah, the very middle, origin. So you would leave that one blank, but I usually just bold the point to remind myself I didn't forget to answer it. Now, everywhere x is 0, you get a 0 numerator, which would be a 0 slope. So these are all going to be 0 slopes. So it looks like just your tick marks. And wherever y is 0, you get a 0 denominator, which means undefined. So again, it looks like just the tick marks of your graph. We're basically only going to need to do quadrant 1, and then what's going to happen? It's just going to reflect. All right. So at the point 1, 1, what do you get? 1. And you can even just go ahead and reflect that everywhere else if you want to. All right. Actually, the same thing is going to happen at 2, 2, because at 2, 2, you're going to get 2 over 2, which is 1. So you can kind of knock a few of them out at once. All right, how about at 1, 2? X is 1, y is 2. 1/2. So you just need for that to be like not as steep. So something like that. It looks cool once you like fill the whole thing. It's kind of like a spider web or something. All right, and then at 2, 1, you get 2/1, which is 2, so it's like more steep. You see that? And then you can reflect it. So something like that. Again, on your test, it's matching, so you'll just have to pick the one that matches. But that looks cool. Okay, where will this have 0 slopes? Well, you're going to take this thing and set it equal to 0. Welcome back to algebra class. What can you factor out? Y. So you're going to factor out a y. That'll leave you with x minus 1. And so you get 2 answers. You get y equals 0, and you get x equals 1. So 2 answers. Set the thing equal to 0. Where does this have 0 slope? Well, again, you're just going to set the whole thing equal to 0. But if you multiply over that 6, 0 times 6 is still 0. So you're basically just setting the numerator equal to 0. How does that one factor? Yep, good, perfect. And so your answers are 5 and -5. Cool. Yep. Oh yeah, or you can do it that way. Just don't forget the plus and minus, although it's gonna be multiple choice, so you probably won't be able to forget. All right, draw some graphs whose slope fields depend only on the y coordinate. If it's only y coordinate, that means you get whole rows that are all the same. Do you see what I'm saying? So it could be something like this. It could even increase a little bit, or it could like decrease a little bit. Basically, the only thing it cannot do is bend back on itself. So it could not do something like that. Like that is a no-no. Do you get what I'm saying? It's going to be multiple choice. So you'll be able to pick the answer, but basically it just can't bend back on itself, or you don't end up with rows that are all the same. All right, bacteria in a culture increase at a rate proportional to blah, blah, blah. That means PERT or KECT, all right? Number of bacteria doubles in 6 hours. In how many hours will the number of bacteria triple? They did not tell us how many we started with. Let's make it up. Just give me a number. 3. Let's say we start with 3 bacteria. I said just make something up because numbers are easier to deal with than variables. So I said, let's just invent something. Now, if they're going to double, how many do you end up with? So 6, and they double in 6 hours. So 6 gets put in for the time. Now we're going to solve it. And this is non-calculator, so we're going to have to power through without a calculator. You would divide over the 3. Oh my gosh, it came out to 2. Isn't that crazy? Because it says doubles. Then what? You want to get rid of E. ln, good job. And then divide by 6. So we're going to start over at the beginning. I'm going to recopy this, but now we know that K is ln of 2 over 6. Again, just trust the process. Fine. Actually, some people prefer writing that to a weird decimal, which it seemed like you guys kind of did. And you don't get a calculator for this anyway. Now it says, in how many hours will it triple? If you started with 3 and it triples, now you have 9. And then we're just going to solve that. And whatever we get is our answer. So if you divide the 3 over, you get 3, which should make sense because it said triples. Then what? ln. Almost done. How would you get rid of divide by 6? Yeah, multiply by 6. And then your last step, I know. And you're doing the same thing over and over and over again, just pushing numbers around on the paper. I don't love that problem, but it's not particularly hard. You just have to kind of do the same thing twice. Mhm. I mean, no. Oh, well, yeah, actually no, just leave it like that. Can we just not? Can we just, can we just leave it like that? Yeah, let's just not do that. Okay. All right. A dose of 500 milligrams of medicine is administered to a patient. The problem that I just picked numbers. So don't make fun of me that it didn't work. Okay. All right. So we start with 500. Are you okay? I don't need to catch whatever that is. Are you?
It's gone.
Oh, okay, good. Okay. 500 is what we start with. And it says the rate at which blah, blah, blah is proportional. That means pert or kect. It says write a possible expression. Here's the thing. The rate needs to be negative. Why would the rate need to be negative? Because the medicine is leaving. Give me a negative number. We'll just make something. I don't know that it'll leave your bloodstream that fast. You would have one heck of a liver. Let's do -2. It's just an example. What did you say? 5. Yeah, that's still a lot. I'll change it to 5 because you seem sad I didn't pick your number. The point is it's negative. Okay. Now using number 16, write a possible differential equation. So it would be dy dt equals. Yeah, that's it. Well, do you see how it was the -5 and I just used the -5? Like that's all that is. It's multiple choice, so you'll just pick the one. But yes, I didn't put choices on here, so we made it up. But the point is that it's negative because it's leaving your bloodstream. Your body is like metabolizing it. All right, free response. Using this differential equation, sketch a slope field. So let's go ahead and draw one. Again, we're going to go 2 in each direction. On your test, I printed a grid for you. And I don't remember if I was explaining this to you in here. I don't know how this is going to go for you guys this year. So you will have to come back and tell me if they even asked you to make a slope field, but if they did they give you a grid? I would certainly hope so. It'd be so mean if they didn't. Correct. All right, indeterminate point is going to be 0 over 0. So again, that's the origin. Wherever x is 0, you get a 0 numerator. So again, this is going to happen here. You get your 0 slopes, and then where y is 0 in the denominator, you get your undefined slopes. So again, it's going to look like that. I'm just kind of bolding my axes there. And we're going to have to go through point by point. I think it is good. Yeah, you know what? It is going to reflect, though. All the positive ones are going to reflect over here. So let's start with this point right here. 1, 2. If you plug in 1 for x and 2 for y, that's -5/4. That's practically -1, like slightly more negative than -1. But again, it just has to be like good enough, right? How about 1, 1? That would be -5. So that's like a good bit steeper. All right, 1, -1. That would still be -5, right? So same thing. And then 1, -2, what would that be? -5/4? Oh, so same as this one. Sorry, sometimes I have to write myself a note off to the side to like figure it out. All right, 2, 2. That would be -10/4. So is that -5/2, -2.5, somewhere in between these. So like, I don't know, maybe like about like that. And then 2, 1 would be -10, practically vertical. And then these are going to be the same. You can just copy them down over here. And then you can take those and reflect them to the other side. So something like this. I I don't know what that would be. It looks kind of like a fish, sort of. See what I'm saying? Like,
Yeah.
doesn't it look kind of like a fish?
Not.
I don't know, whatever. That's what it is. That's the answer. Let's move on. All right, write an equation of a tangent line. What two things do you need to write an equation? A point and a slope. Good job. The point is, yep, they gave you that. Slope comes from derivative. This is your derivative. So you're going to plug in 2 for x, -1 for y. So -10. So put it all together. It'll be y plus 1, perfect. -10 parentheses x minus 2. Now, we're going to use it to make an approximation. You have to pick a number that's really, really close to 2, which they did, 1.9. So y is approximately, please don't try to evaluate this. Just leave it alone. It'll be -10 and then parentheses 1.9 minus 2. And then what do you tack on at the end so you get the y by minus what? Please leave it alone. I remember the last time one of these showed up on there and some of you tried to evaluate that and then was wrong. And then I had to mark it wrong. And I was sad. All right. Find the particular solution with this initial condition. All right. How would you separate this? Times the y squared. And then multiply over the dx. All right, antiderivative for y squared. Yep, 1/3 y cubed equals. All right, that's the step we're going to come back to. We're going to plug in 2 for x and -1 for y. So if y is -1, that's -1/3. Oh, geez, this is going to be fractions here. All right, and then 2 for x. 2 squared is 4. Divided by 2 is 2 times -5, -10. I need for that to be thirds though. So I'm actually going to erase it and turn it into thirds. It would be -30 thirds. Perfect. So if you add that over 29 thirds, great. So you're going to go back to the step where I put the arrow, recopy it literally exactly, except put the plus 29 thirds. And then you've got 2 more steps. Times by 3, and then I'm going to do them at the same time so I don't have to recopy it again. Cube root. So you're doing 3 times all of that, and then a cube root. If it looks like a disaster, take 2. If it looks like a disaster, you probably did it right. Is how those turn out. What's that? Yes, that was a free response. Yes. Yeah. Oh, they had to match. It said using question 16. So see how that was a -5 there? That's the rate. Or if you think of PERT, like that's the R PERT, that's your rate. Actually, I'll give you guys another break because I know this is Monday and you're hanging in there. Let's do number 19 and then I'll give you another break and then we'll do the calculator ones. All right. All right. I threw a related rate in here because they do this. All right. I believe in you. Water is being poured into a cylindrical container. If you need a visual, this is a cylinder, like a soup can. Okay. The radius is 3 centimeters. It is not a magical growing can. That is 3 centimeters. The amount of water in it is going to change. All right. But the can itself is not changing shape. That would be Twilight Zone. Okay. So that's 3. That's not going to change. Right. And the height is 30. Again, not changing, constant. The amount of water is going to change, but not the actual can itself. All right. The height of the water is given by h of t, which I guess we don't have. We have centimeters and we have seconds. Volume is changing. So what is this then? If it's how the volume is changing, what would we label that as? Good job. dV dt. And it's positive because we are filling up with water. Instead of filling up with water, it's leaking out. Do you understand? Okay. Show that this is true. They're basically saying that's the answer. Just prove it. All right. Volume of a cylinder. I'm pretty sure it's on the test. If it's not, I'll give it to you. Well, let me throw the question out there. Does anyone know volume of a cylinder? There's a pi in it.
1/2 pi r squared.
That's not even three-dimensional, but
Oh.
H, good. It's the circular base times the height. All right, now what is our radius, which isn't changing? 3. So 3 squared, 9. So it's 9 pi h. And then we're going to do a derivative. So dV dt equals, what's your derivative of 9 pi h? And do not overthink it. It's 9 pi. Hey, Miss Cole, I'm scared I'm going to forget the dH dt. You won't, because what does the problem say? To show that, you're going to go, oh, I missed a dH dt somewhere because that's what the question's asking. All right, what is dV dt? Because they gave that to us. Yeah, that thing right there. So it's going to be 2 pi square root of h equals 9 pi dH dt. And then we're almost there. We just have to get dH dt by itself. Also, what's going to cancel? Yeah, pi's cancel. And how would you get dH dt alone? Yeah, divide by 9. So it's 2 square root of h over 9, which holy moly is the thing that they said right here. So we know we did it right. All right, B, given that the height is height of the water, not the can, right? Given that the height of the water is 12 centimeters at time 0, solve the differential equation. I would rewrite this as h to the what? Square root is h to the, good, 1/2. Now, when you divide that over, here, don't write this, but it would look like this if you divided it over. So how should we write that? Yeah, negative 1/2 dH equals, and then what's still there that I didn't move? Yeah, 2/9 dt. You're going to add 1 to the power, which is good. It won't be negative anymore. If it's negative 1/2 plus 1, now it's 1/2. So in front of that 2, this is a little bit tricky on the other side. Just remember, it's not x, it's t. So antiderivative of 2/9. 2/9 t, good, plus c. All right, we're going to plug in, gosh, what are we plugging in? 12 for h. So this will be, now you can write 12 to the 1/2 if you want. I'm going to go ahead and just write square root of 12. Equals, oh good, time is 0, so that's gone. Yay. You're going to recopy this, although I'm going to make it a square root, and put that 2 square root of 12 in there, and you have 2 more steps to get h by itself. I'm going to try and do them both at the same time. What would you do first? Yeah, divide by 2. I would literally just go like that, and then square it. I don't want you to rewrite it, because if you do a copy error, it's going to be wrong. So just do that. Now, part C says, at what time is the container full? On yours, it's leaking. So it's going to say, at what time is the container empty? So it's actually going to be easier on your test. If the container's empty, you would set the height equal to 0 because there's no more water. I had to do it the other way around because I made this one filling up. At what time is the container full? You're going to take this height that you just found and set it equal to, well, what is full on the 30? So you're going to take this mess and set it equal to 30. I am, again, not going to write a whole lot here. I'm going to talk you through the algebra. What would be the first step? You would square root. We don't need a plus minus because we're talking about a length of something, so it can't be negative. All right, then what? Multiply by 2, so it's going to be 2 square root of 30. Then what? We're still trying to unbury the t there. You subtract the 2 square root of 12. And here, I'll rewrite it once for this very last step. To cancel out a 2/9, you would do 9/2 of the whole thing that we just had. Yours will be easier because it'll be 0 and it'll be an easier number to work with. All right, but you just take that height that you found and set it equal to what they asked. I don't love that part C is based on part B. So if you can't get part B, you're not going to be able to get part C. But life is like that sometimes. Now, just because you're allowed a calculator doesn't mean you'll necessarily need it. For example, number 20, I don't think we're really even going to need the calculator for this one, but that happens. When you took your SAT, did you notice that? Like on the non-calculator, you're like, wow, I really wish I had a calculator now. And then on the calculator ones, you like don't even need it. Yeah. So like it's going to be like that here too. All right. The slope field is shown. This is f of x, particular solution through 0, 1, and then h of x equals this thing. Find h prime of 0. So we're going to find h prime of x, and then we're going to plug in 0. If they ask you for h prime of 0, that's how you want to set it up. Now, what rule do you need for that derivative? Product rule. Good. So we did one earlier. How does product rule start? Yep, the first thing, 8x. Good. And derivative of f is just f prime plus second thing times derivative of the first, which is just 8. So now we're going to go on a little scavenger hunt and find all this stuff. So if you plug in 0, 8 times 0 is 0. I realize that's going to turn that whole thing into 0, but I can't remember if that happens on your test or not. So let's actually find f prime of 0. Derivative means slope. This is the point that we're looking at, 0, 1, which is right here. So you need the slope of this line. Negative 1/2. Good job. Again, I realize that whole thing is going to turn into 0, but I don't remember if it does that on your test. So I wanted to go through finding that. All right, plus f of 0. Well, it's the point 0, 1. So 1 times 8. And so that whole thing just comes out to be 8. You'd be allowed a calculator if you wanted, but it's just 1 times 8. It was the point 0, 1, so f of 0 is 1. If you want to think of it that way. I didn't know if it was a question or not. Okay. If I don't know what's going on, I tend to just mimic. I'm like, all right. During a certain epidemic, number of people infected at any time, blah, 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 increases at a rate proportional to. That is a really fancy way of saying it's going to be PERT, okay, or KEKT. 1,800 people are infected when the pandemic begins. So that's our 1,800 goes there. 2,300 are infected 8 days later, like Walking Dead. Okay, so where does the 2,300 go? No, that's Y. And then what does get plugged in for T? 8. And then you solve that. So what do you do to both sides? Divide by 1,800. Now, I know you get a calculator. Try to focus. We only have a couple more. Don't reach for the calculator until the very end, okay? This is going to be ln of 23/18 equals k times 8. And then your last step is divide by 8. Okay, so now you want to type that in the calculator, but wait until you get to the end before you go into that. Let's all type that and just make sure we can all be friends with our calculator and get the same thing. I got 0.0306. I don't hear any complaining, so I'm gonna assume we're good. Okay. Now we're gonna start over. We're gonna recopy this, but I'm gonna put in that, oh gosh, what was it? 0.03. It doesn't matter because I'm gonna copy paste that at the end anyway. And then we can answer the question, what do we want to plug in for time? We want how many people are infected at 12 days. So what you're going to type into your calculator is 1800 e the power. Now you want this number times 12. So if you highlight it, you can copy paste it in there and then times 12. You know how to do Control C and Control V? Like copy paste? And we will round to the nearest whole person. So 2,600 people. What is going on? All right, number 22. Number of bacteria in a culture in grams is decreasing. I guess we're killing them. All right, usually bacteria is increasing. So funny. Okay, I guess we're disinfecting. Decreasing according to this model. Can you look at this? Because this is where you have to understand the difference between these two models. Do you see how it is proportional to? It's negative 0.03 times something. Okay, so your A equation is PERT. And do we have how many we started with? Oh, we do. Can you read through for culture A? How many did we start with? 5. Do you see that there? So it's 5e to the power negative 0.3 times t. So I pulled out that information for A. The initial amount was 5, and then that's your rate. Now there's going to be another one for B. That one is different, though. It's not going to be PERT. Do you see how the rate is just negative 1.5? What does that mean? Say that a little louder. It's a constant rate. Do you see that? It's just negative 1.5. Okay, we're almost there. If it is a constant rate, what kind of a graph is it going to be? Because it won't be a swoop. Linear. Perfect. Y equals mx plus b is what we're doing. So it's negative 1.5 t plus, what was the initial condition for B? You have to go find that somewhere, 7. I am so glad that you said constant. I was hoping somebody would say constant. Do you see how that's a constant? In fact, that's so important. Let's write that down. Constant rate means linear. What are you doing? What is this question asking? Because we're not quite done yet. Okay, what you're going to do is put both in here. Now, you can't type P. What are you going to need to type? X. Get it together. Everybody. You're going to type, oh, oops. You're going to type them both in, preferably in different spaces there. There we go. So one should be a swoop. See how the swoop is going down? The other one should be going down as well. Hold on, I missed the negative. There we go. You see how I caught that because I was paying attention? I was like, hey, they should both be going downwards. Okay, now we want where they are the same. So click on that intersection. What time are they the same? 3.5 seconds. Well, the other one would be negative times, so we can't use that. 3.5 seconds. Unless you've built a time machine, you don't want the negative one. You'll bring it next time. Okay. And so I can go backwards and change my life choices. Okay. The population of a city grows at a rate proportional. What does this mean? I keep Kurt, thank you. Okay, because you have to know what it's going to be wordy, but you have to know what that means. Population doubles every 7 years. What is the value of K? They didn't tell us how much they started with. So what do you want the population to be to start with? Just give me
17.
Let's go with 5. That's good. Okay. So it'll be 5e to the kt. But we want it to double. So that would be 10. And it doubles every 7 years. Good. So 10 divided by 5 is 2. If you don't want to make up a number for the population, you can just skip that and go ahead and put a 2 in there. But sometimes that bothers people. So that's why I like to just make something up. All right, 2 equals e to the power k times 7. Then what? ln divide by 7. All you have to do, all we asked for was k. So all you have to do is type in ln 2 divided by 7. So everybody give that a shot. Make sure you can get the right answer. .099. Color George for next time and also do your AP classroom.